Okay, we covered the Egyptian numeric symbols before, and one of the specialty for that system was they just assign some symbols for every powers of tens, and they just to put as many symbols they need to denote any number. Now, it sounds like it's okay and it's working, but the problem is for any calculation, like simple addition and subtraction is okay because they only simply adding some more and subtracting from the given number, they could do that. So it was not a problem. But when they want to have a multiplication, and if it's not just simple by times by 2 or times by 3, but how about times by 27? Then it's not that kind of calculation for that time period with this type of number system. Okay, so they actually invent some kind of clever way to handle those, which still requires a lot of very difficult calculation compared to what we are doing recently, but still with their own number system, it's kind of sounds kind of okay and kind of clever. So we are going to cover that one in this chapter. So please remember this. Their symbols for numbers are like this style. Okay? It's not like what we are using right now, but for what we want to do here is not just following exactly what they did, but to get the concept of how they figure out those multiplications and divisions with their number system. Okay, so we are going to use our own numbers, but remember they have to write down their number like this style, and just imagine multiply by itself. Okay? Then how are we going to do that? It's kind of, we have no idea because it's not positional number system, so we cannot use the simple multiplication procedures. So what they did was inventing this kind of doubling method. So let's say, so let me just use this example to explain it. Let's say they want to multiply 45 and 73. Doesn't matter which one we use, but putting the smaller number at here is better, but actually it doesn't matter. And the method is try to start with the number 1 and try to get the double of those numbers and matching that one by the other number that we want to multiply. So by doing that, we need to calculate the doubling of that. So one thing we should careful about here is doubling of 73 in our number system is not a problem. Okay, like this, we know how to do this. But just imagine this one with their own number system. So writing down the 73 with their symbols, it requires some time and effort for that, right? So like a 70 of 7 of these notations, right? And 3 means 3 parts like that. And we need to double of it. So, okay, that could be 6, and that should be 14 of it. But instead of 14, or maybe they might do this way, right? Write down that, and whenever they found 10 of these pieces, then they go to the next symbol. So 100 means like, not dots inside, so like this, right? Then they found out, oh, the notation should be this one and 4 of this and 6 of that. You follow me? Then how about double of this? In this case, like a doubling means like that, right? And once again, double means 12, right? So we need another one over here. But it's kind of simpler than try to calculate 45 and 73 multiplication of those, right? It's really, we have no idea, right? How can do that, right? So that's the entire situation right now. So making double is just write down twice of the given symbols. So they could do that, and that was the kind of idea how they could calculate it. So please keep that on in your mind. we are using our own numbers and symbols like that, but what they did is using their own symbols and using only their own style of arithmetic, right? So it's way, way more difficult than what we are doing right now, okay? So 73 is matching to number 1, then make it double. So 2 is matching to 146, then make it double again. So 2 change to 4, and double of 146 is 292, and we just keep doing it until we hit this number. Sometimes that number is kind of doubling of this number 2, right? Or actually powers of this number 2, but it's really make it square, make it square. So it's not simply uh, kind of taking the powers of 2, right? You can think that way, but in Egyptian time period, they didn't have such a thing, so it's simply just double of the previous number like that. Then this given number might be that double of those numbers, right? But if it's not, there must be 2 numbers surrounding that given number. So in this case, 32, and when it doubled it, we got 64. Then this given number 45 is between those two. Then that's the time we start. Okay, so we start doubling, starting from 1, and we did it until we hit certain number which is greater than that number. Okay, and that's the time we have to stop. Then at this moment, all we need is how to get that 45 from this left hand side, or the first column. Okay? Of course, not the last number, because we are not going to need it. So combination of those numbers will make 45. It's guaranteed. So how about 32? And when you're adding up 16 to 32, we got 48, which is greater than 45, which means what? 16 is not. Then adding up 8, then the total is 40. Then we need 5 more, which means 4 and 1, right? Then look at the corresponding numbers. 73, 292, 584, and 2336. So it's kind of big summation, right? The first column, we adding up 1, 4, 8, 32, which makes 45. And that number matching to the sum of the second column of those selected numbers. So it's going to be 73 plus 292 plus 584 plus 2336. And the total is going to be 3285 or something like that. Now, let's look at here. Even adding those numbers is not kind of easy calculation for them, right? They have to adding all these symbols together and checking which one gets more than 9 same symbols. Then they have to carry over one, like that. So it's really long procedures of this. But if you just imagine to take multiplication of 45 and 73 with their own system, then this is really, really simple calculation for them, right? So whoever invented this method is really clever person, okay? Or maybe efforts of several people, right? But anyway, so this is how they calculate for the multiplication in that time period. So the next one is the practice for that. So please do. So my suggestion is smaller number at the corner, top left corner, and 1 is matching to 25, right? And keep doing it, and we can do that. So that's the multiplication. Then how about division? That's going to be a very similar situation, but in this case, it's kind of reverse of the multiplication. Okay? So let's say we are going to divide 377 by 13. Then the method is matching number 1 with this smaller, or the divisor, right? In this case, it's not smaller, it's divisor. So 1 and 13. Then still using the same doubling method. So 2 matching 26. and keep doing it. 4, 8, 16, 32 until we hit that number. The dividend 377 is between two numbers on the second column. Okay? Then we know that's the time we have to stop there. Then actually that's all. All we need is up to this much, right, from the second column, by adding some terms, which makes that 377 directly. Okay. So in this case, if you want, you can put that dividing over there and try to get the number by adding some numbers on the second column. So how can you start it? Starting from the greatest number. Okay, so 208 and adding by 104 is we got 312, which is still less than that. Then we include those two. Then adding 52 there, then altogether is 364. That's good. Then adding 26. Then it turns out the result is 390, which is greater than that, which means what? We don't accept this one, which means we don't include 26. Then go to the next number, which is 13. So when you add these two, 377. It's guaranteed. Okay. So we know that we have to include those numbers except 26. Okay. Then be careful. And how can you write down the answer for that? The answer is what is the corresponding numbers on the first column, which is 16, 8, 4, and 1. Right? So we're just adding up those results. We already checked on the right hand side, when you're adding those numbers, we got 377, which we want to get. Right? So on the left hand side, we're just adding up those matching numbers, like 1 plus 4 plus 8 plus 16, which is 27. Right? Then that should be the quotient. So the result of those division. Okay? So we know that 377 divided by 13, then 2 means 26, then it's 117, and multiply 7. Okay, it's not 7, right? It shouldn't be. Something is wrong, so let me check. Yeah, yes. So it's what? I thought it's 10, but 12. So it's not 27, but it's 29, right? Okay, sorry. So it should be 29, of course, right? So 27 and 1 is 11, so like that, right? So when you take, this is our method, right? So it's a very easy way to get it. But for them, they didn't have this nice multiplication and division procedures because the main reason is their number system is not positional system. Okay? It's just simply adding up something like this. So they just use this doubling method for multiplication and division. Okay? So be careful which one is which and how to get those. But by doubling method, they could get the answer for that.